Example B wants us to solve a triangle that has an angle A of 31.10 degrees, a measure for angle C of 112.90 degrees, and a side length B of 347.6. Now this one we don't have a triangle for us, so let's draw a triangle. And one thing that I might have forgot to mention, but you've probably come to this realization, is that the capital letter A is the angle and it corresponds to the side length A that's lowercase. So if I have an angle A here of 31.10 degrees, so if this is capital angle A, then that means that this side length is going to be lowercase a. And we know that this is lowercase b, and that is 347.6 degrees. Oh, not degrees, just units. And then this is angle capital C, and that is 112.90 degrees. And so that tells us that this is side length C. And then this would be angle capital B there. Okay, so here we have the angle side angle scenario, and we are going to use the law of sines. So the first thing that we want to do is we want to figure out what angle B is. And I'm going to use a calculator this time. So I know that I can do 180 minus the sum of the other two angles. And so that tells us that angle B is 36 degrees. So, all right, so now we have all of the angles in our oblique triangle. Now we need to find the other two side lengths. So I know that sine of 36 degrees over 347.6 is equal to sine of 31.10 degrees over the lowercase a side length. So if I cross multiply, I would get a times sine of 36 degrees is equal to 347.6 times sine of 31.10 degrees. I forgot to put the degree symbol there. There we go. And then if I divide both sides by sine of 36 degrees, we get a is equal to 347.6 times sine of 31.10 degrees over sine of 36 degrees. So let's throw that into our calculator. And then I want to divide that by sine of 36. So that gives me 305. For whatever reason, this question gave us angles to 2 decimal places. So why don't we round this to 2 decimal places? So 305.46. All right, and then the last thing we need to do is solve for lowercase c. And I'm going to write that down here so we can fill that in just a moment when we solve for it. So let's do this. Sine of 36 degrees. What's really nice about the law of sines is that you can swap the ratios because they're equal. And what I mean by that is you can flip the numerators and the denominators. So it also holds true that 347.6 over sine of 36 degrees is equal to lowercase c over sine of 112.90 degrees. And that makes things a little bit easier because now I can just multiply both sides by sine of 112.90 degrees. And if we do that, then we get c is equal to 347.6 times sine of 112.90 degrees over sine of 36 degrees. And that's also really nice that it has that property that you could flip the numerator and the denominator on both sides of the equation and that they'll still be equal, because in the past, previous students have told me that they have trouble memorizing the formula, but it makes things a little bit easier knowing that you can actually swap the numerators and the denominators as long as you do it to both sides of the equation. Okay, so we end up getting c is equal to 544.76, and I'm just going to fill that in on my little triangle drawing, and that completes this example. We found all the side lengths and all the angles. Okay, so for the side-side angle scenario, which we call the ambiguous case, we may have no triangle, one triangle, or two triangles, and the possibilities are outlined in this graphic here below. And notice that h in this case stands for the height of the triangle. And so the first scenario is that if you have a side length A here and it is less than the height of the triangle, then you don't actually have a triangle. The three side lengths would not be connected, because if I had my height of the triangle here and it was longer than this side length, then that wouldn't actually form a triangle because there would be this open gap here. And the second scenario is if the side length A is equal to h, then they'd be the same and you would have a right triangle. Now, if A is more than h, but A is less than B, where B is this side length here, then what can happen is you can end up with two triangles, one where A is going like that, or where A is going like that. So you can really form two different triangles. Sorry, let me outline them. So this is one possible triangle, or there could be this triangle here that would satisfy the conditions that are given to you. And then the last case is if A is greater than or equal to B, then you have one triangle that looks like that. So let's go ahead and look at an example of this. All right, example 2 wants us to solve the following triangle, where capital A is equal to 42 degrees, lowercase a is equal to 70, and lowercase c is equal to 122. Now, I went ahead and I drew the triangle that I thought was going to help me solve this problem, so feel free to pause the video so that you can draw the triangle as well. And I went ahead and I used a solid line or curve to represent a known angle or known side length, and then a dashed line or curve to represent an unknown side length or angle measure. So I'm also going to fill in the height of this triangle here. So I'm going to draw a line straight down, and I know that this forms a right angle and that that is the height there. And I'm going to call this height h, and I'm going to try to figure out what h is before I do anything else so I can kind of see which of the four categories it falls into on the graphic that we just saw. And notice that this forms a right triangle. So that forms a right triangle right there. And so since I have this right triangle, I can use the trigonometric functions to figure out h. And so what I'm going to do is I know that, let's see, we have h, which is the opposite from capital A, and then c would be the hypotenuse. And so that tells us that we're going to use the sine function since we'd have the opposite over hypotenuse. And if I multiplied both sides by 122, we would get h is equal to 122 times sine of 42 degrees. And if I throw that into my calculator, that gives us 81.63. And notice that the other side lengths and angles are all given in whole numbers. So I'm just going to round that to the nearest whole number, which is 82. So this is 82 here, which tells me that I have not drawn this triangle correctly because this side length here is definitely not to scale and it needs to be shorter so it would look something like that, which tells me that, look, there's a gap here and it's not actually connecting. And so what that tells us is that because our height is greater than A, we have no triangle. So these measurements that are given do not form a triangle, and that concludes this example.